Hey everybody, Chapter 2, Lesson C, Real Zeros of Polynomial Functions. Now we have, up to this point, done some solving and finding zeros of polynomial functions using factoring methods, quadratic formula, a method called factor by grouping. We've used the calculator to find zeros. Today, we are going to use long division and synthetic division to both divide polynomials as well as find their zeros. So in order to do some long division, I thought I'd go over the old school long division method of dividing numbers. So let's do an example here. Let's divide 7 into 3,147. So first thing that we do is, of course, 7 does not go into 3. But 7 does go into 31 4 times. So our process here is then that we'd multiply 4 and 7, getting 28. We would subtract 28 from 31, which would give us, what is that, 3. We drop down our next number, which is 4. We see how many times 7 goes into 34. It also goes into 34 4 times. So that 4 now times 7 is 28 yet again. We subtract again, we get 6. We drop down the 7, and we get 67. 7 goes into 67 9 times. 9 times 7 is 63. And we subtract, getting a remainder of 4. 7 does not go into 4. Therefore, we have a remainder. So 3,147 divided by 7 is equal to 449 and 4/7. We're going to do that with polynomials today, so let's go ahead and get started. Okay, so we're going to do some long division of polynomials now, considering this function f of x given below. If it is known that x equals 2 is a zero of f of x, use long division to find the remaining zeros of f of x and graph the function. So we've got this cubic function. As I look at it, just some general things that I notice. Our leading coefficient is 6. Our leading term is 6x cubed. Therefore, our end behavior should look like this. So I know what the function will look like, at least on the ends. If x equals 2 is a 0, then x minus 2 is a factor. So the way I could find the other factor is if I divide 6x cubed minus 19x squared plus 16x plus 4 by x minus 2. So I'm going to divide x minus 2 into our function f of x. 6x cubed minus 19x squared plus 16x plus 4. Okay, now when we do long division with polynomials, all that I ever really care about is x minus 2. Okay, so I'm going to plug x minus 2, divide and see how many times x goes into 6x cubed. Okay, so how many times does x go into 6x cubed? It goes in 6x squared times. Think about that now. X times 6x squared is 6x cubed. So I'm going to multiply through. That'll give me 6x cubed. The 6x squared times negative 2 is negative 12x squared. I always put parentheses around when I divide, and the reason for that, you'll see in just a moment, is sometimes you forget to distribute, but negative 19x squared minus a negative 12. Of course, I'm going to get 0x cubed here, because that's what I'm attempting to do. I'm trying to eliminate that term, so that'll disappear. So I'll get negative 19x squared plus 12x squared. So that'll be negative 7x squared. Now I'm going to, just like I do before in normal long division, I'm going to drop down the next term, and I'm going to see how many times x minus 2 goes into negative 7x squared, and it goes in negative 7x times. So now I multiply through, I get negative 7x squared and a positive 14x. Subtracting those, the negative 7x squareds reduce, and 16 minus 14 is 2x. And I drop down the 4. Okay, now how many times does x minus 2 go into 2x plus 4? It goes in twice. So I'm going to multiply through. I'm going to get 2x minus 4. Okay, it looks like I'm going to get the 2x's to reduce. Uh-oh, I got a problem. Okay, so my problem is totally jacked up. X equals 2 is not a 0 of this function. So I just did a problem that doesn't work out at all. Your teacher is not perfect, other than my hair. But let's just write this out. We're going to scratch the graph because we don't know that this is a 0. But we'll get to some solving in a little bit. So what we can say is that 6x cubed minus 19x squared plus 16x plus 4 divided by x minus 2 is equal to 6x squared minus 7x plus 2 plus 8 over x minus 2. Notice I took my remainder over that value, and this would be my answer. Okay, clearly we'd like for this remainder to be 0 if the original factor is actually a factor, if the original divisor is a factor, right? So that would turn out to be 0, and we get something nice, and we could potentially factor what's left to find the other zeros. So let's move on to another example here, and we'll see if we can do a little bit more with the long division. Okay, in each of these examples, what I'm going to do is use long division to determine whether x plus 1 is a factor of these functions. So let's go ahead and do some long division. So in the first one, I'm going to take x plus 1 divided in x squared plus 3x plus 5. So x times x gives me x squared. I'm going to multiply through, giving me the following. Subtracting, I get 2x, dropping the 5 down, I get plus 5. X goes into 2x 2 times. Multiplying through, it looks like I get 3. Therefore, x plus 1 is not a factor of f of x. Okay, let's do another one here. Let's go x plus 1 divided into, oh, that was crazy, 2x to the 4th plus 7x cubed minus 4x squared minus 27x, my goodness, minus 18. We got some work to do here. So x times what gives me 2x to the 4th? Well, that would be 2x cubed. I multiply through, I get 2x to the 4th plus 2x cubed, parentheses, subtract, gives me 5x cubed. Drop down the next term. Oops, I didn't mean to do that. Okay, x times 5x squared gives me 5x cubed. And then I'll get a plus 5x squared when I multiply by 1, subtracting. I get negative 9x squared. I'm going to drop down this negative 27x. Okay, that would mean I need a negative 9x. Gives me negative 9x squared. You're starting to get the pattern, I'm sure, here. Okay, subtract. Okay, and typically the errors happen in the algebra. So here what I would get is a negative 18x, right? This is negative 27 minus a negative 9x. I'm going to drop down the negative 18. So I need a negative 18 here. Negative 18 times x is negative 18x, and negative 18 times 1 is a negative 18. So if I subtract this from itself, look at that, I get 0. So x plus 1 is a factor of g of x. So what's kind of cool is if x plus 1 is a factor of g of x, then guess what g of negative 1 would equal? that would have to equal 0, right? Because if this is a factor, what we've done before is we've found the value that would make that factor equal to 0. It's called the factor theorem. So we're going to get to that in a little bit as well. Okay, next slide, just a couple of examples. I would, if I were you, pause the video, attempt these, and then come back and check your work with me. Okay, so I'm going to take f of x over g of x. So that means I want 2x minus 1 divided into 8x cubed. Now, seeing that I'm missing a few terms here, I'm going to just put some placeholders in. Okay, and then I'm going to do my work exactly how I did before. So 2x goes into 8x cubed, 4x squared times. That gives me 8x cubed. I multiply through, and then I subtract. That's going to give me positive 4x squared. I drop down a 0x. Okay, and then yet again, I multiply through. So I would need a plus 2x to get a 4x squared. So that would be 4x squared. And then a minus 2x. Okay, if you don't put those placeholding zeros in there, you're going to have algebra issues here. Okay, the 4x squareds again cancel. I get a 2x. I drop down, look at that. I drop down a negative 1. I would need a 1. And that, of course, would give me this, 2x minus 1. So that is a 0. So if I do long division, okay, f of x divided by g of x is equal to 4x squared plus 2x plus 1, provided that x is not equal to 1/2. Because if I do f of x over g of x, I don't want g of x to equal 0. And g of x would equal 0. X cannot equal 1/2. Very good. So this would be our answer to f of x over g of x. Okay, let's do another example here. This one's getting a little nasty. So I'm going to take x squared plus 2x minus 3 divided into 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. Okay, so now I have to consider a little bit more here. I'm going to be dropping down multiple values due to the fact that this expression out here, the divisor, has 3 terms. So I'm going to multiply by 2x squared to get 2x to the 4th. I multiply everything through. Oops, that would be 2x to the 4th. 2x squared times 2x is plus 4x cubed. And 2x squared times negative 3 is negative 6x squared. Okay, we subtract. We would get nothing. We would get nothing. We would get x squared. Now I drop down a 3x. And I drop down the negative 2. Now I can see that these are not the same. Therefore, I'm going to put a plus 1 here, and I'm going to multiply through. So this is going to get kind of interesting, but I'll just get exactly what I have over here. And when I subtract, x squareds reduce. I'm going to get an x and a plus 1. This is very interesting. So f of x over g of x is equal to 2x squared plus 1 plus x plus 1 over our divisor, x squared plus 2x minus 3. So I can't have x equaling a value that would make g of x equal to 0. So let's see if I can factor this. Minus 3. So x and x, that would be a plus 3 and a minus 1. So x can't equal 1 or negative 3. Okay, very good. Long division. Now we're going to take this to the next step and start talking a little bit about solutions and zeros using this process. Before finding zeros and looking at solutions to some of these polynomial equations, I do want to introduce you to synthetic division. Very similar to long division. It can be advantageous to use this in certain situations. It's less writing. Does the same exact thing for you. So I'm going to divide these two using synthetic division. Now, when you use synthetic division, you use no variables. You only use constant values. So I'm going to highlight f of x as 1, -10, -2, and 4. I'm going to use those coefficients. And for g of x, I'm not going to use this as a potential factor as I do in long division. I'm going to use it as a potential solution as -3 or root or 0. Okay, so what I'm going to do is I'm going to align these two, and you'll start to see what I'm doing. Very similar setup to long division, slightly different though. So what I'm going to do, and I'll explain it first, is this is what I am going to be using as my like my divisor as I had in the long division examples. But what I'm going to do is I'm going to drop this 1 down, okay, and I'm going to multiply just like I do in long division. So I'm going to multiply this times this, so -3 times 1, and I'm going to put it right underneath the -10. So that'll be a -3. Now in synthetic division, we add, we never subtract. Okay, so it's kind of the opposite of long division in that way. So if I add -10 and -3, I get a -13. Okay, now yet again, what I'm going to do is I'm going to multiply the -3, but now times the -13. So -3 times 13 is 39. Okay, now I'm going to add -2 and 39, which is a 37. And I'm going to multiply -3 times 37. That is -90, -111. Okay, so I get -111. And what you'll get here in the last spot is the remainder. Okay, you'll get our remainder here. Okay, so our remainder looks like it comes out to be -107. Okay, now this is really important, but this is a quadratic. So this will be our constant term. This will be our linear term. This will be our quadratic term with its coefficients. Okay, and then this will be our remainder. Okay, and when I write this out, I'm going to write it as -107 over x plus 3. So when I take f of x divided by g of x, I get that. Of course, I don't want x to equal -3. Okay, that's synthetic division. Now, it can be very, very useful and kind of speed up the process of what we're trying to do here. So let's keep moving and see how this applies in the next couple of steps. Okay, so I alluded to this earlier, the remainder theorem and factor theorem. And basically what they say is if you have an inkling that a value might be a 0 or an expression might be a factor, if a polynomial f of x is divided by x minus k, then the remainder r will be f of k. So if you think, for example, that x minus 3 is a factor, then what you want to do is you want to test, well, if I want to find out relatively quickly without using long division or synthetic division, I just check to see if this equals 0. Right? Will it equal 0? If it does, then it's a factor. If it doesn't, then x plus 3 is not a factor. So we're going to be testing that in just a minute. Okay, now the factor theorem is kind of the opposite of that, but if f of k equals 0, then x minus k is a factor of f of x. So in example 4, determine if x plus 3 is a factor of the following functions. So what I'm going to do is I'm going to find f of -3. And then in the second one, I'm going to find g of -3. And in the third one, I'm going to find f of -3. If any of those equals 0, then we will know that x plus 3 is a factor of those functions. So let's do a quick calculation here. -3 to the 4th minus 10 times -3 squared minus 2 times -3 and plus 4. That's 81. That'll be minus 90 plus 6 plus 4. That's definitely not going to equal 0. That's going to equal, what will that equal? It's negative 9 plus 10, that's 1. So f of negative 3 is equal to 1. Therefore, x plus 3 is not a factor. All right, let's look at g of negative 3. Plug in a negative 3, square it, plus 2 times negative 3, minus 3. So I'm going to get 9 minus 6 minus 3, and there you have it. X plus 3 is a factor. Now I could factor it and keep going, but I'm not going to do that on the slide. That's not the purpose. Okay, f of x is this whole string of craziness. So let's test this out. Negative 3 to the third minus 5 times negative 3 squared plus 3 times negative 3. That was a terrible 3. Minus 2. This looks like just a ton of work here. So this will be 162. That's 81 times 2. Minus, that'll be negative 27 times 4. Oh goodness, which is 108. Negative 108. Okay, and then 9 times 5 is 45 minus 45. And minus 9 and minus 2. So let's see if this all adds up to be what I'm thinking it will be. That's 162. That'll be 153. And 11 more. Not going to work out. So minus 164. Looks like we get a negative 2. Therefore, x plus 3 is not a factor. All right, cool. That can be very helpful later on. All right, let's get moving. All right, so using synthetic division or long division and the 0 that's given, okay, so the given 0 is, we're stating that it is a 0. Find the remaining zeros of the function. And then I'm going to add in here, we're going to sketch the graph. Okay, we're going to sketch graph. Okay, so let's look at this. Okay, x cubed plus 3x squared minus x minus 3. So I can assume that f of negative 3 equals 0. Therefore, I can assume that x plus 3 is a factor. Okay, so let's do a little division here. So x plus 3. Oh, you know what? I'm going to go synthetic. Yeah, that's what I'm going to do. So I'm going to use negative 3. I'm going to use 1, 3, negative 1, negative 3. And because I know this is a factor, that should be a 0. So I drop the 1, multiply, add, multiply, add, multiply. Look at that. I get a 0. So let's check this out. Then f of x, and we haven't done this up to this point, but it would be x plus 3 times the factor that I have left. This would be x squared plus 0x minus 1. So that would be x squared minus 1. And now I don't need so much space there. But now I'm going to find the remaining factors. So this would be x plus 3. I'm going to factor this binomial to x minus 1, x plus 1. This is very cool. I've got x-intercepts of negative 3, 0, negative 1, 0, and 1, 0. I also have a y-intercept. I'm going to look at the original equation of negative 3. And now I can sketch this graph. Okay, this isn't going to be perfect, but I'm going to sketch this graph based on the fact that this is a positive leading term, odd power. So I'm going to have zeros at negative 3, 0, at negative 1, 0. I have y-intercept at 0, negative 3, and and other x-intercept, or 0 at 1, 0. So the graph is going to pass through each of those. That's a pretty good sketch of f of x. Okay, let's use, again, synthetic division. I prefer synthetic division, provided that the factor is x minus a number or x plus a number, not like 2x or 3x. Then I would suggest using the long division method. Okay, so let's knock this last example out. That'll be the end of our notes for today. I'm given that x minus 4 is a factor, so I'm going to use synthetic division again with 4, coefficients 1, -4, -4, and positive 16. I know based on the information I should get a 0 here. I'll confirm it using algebra. I drop the 1 down, multiply. Looks like I get myself a 0, multiply, and I get a -4. Multiply those, I get -16, and of course that would equal 0. So it looks like g of x would equal x minus 4 times x squared minus 4, right? This is the quadratic x squared minus 4. So if I factor g of x, I would get x plus 2, x minus 2, and x minus 4. That would give me an x-intercept of a -2, 0, a positive 2, 0, and a positive 4, 0. I would get a y-intercept, looking back at the original, of 16. And I can sketch the graph. Kind of cubic, similar in behavior. I've got -2, 0, 2, 0, and 4, 0. And a y-intercept, of course not to scale, of 0, 16. It's going to look kind of like this. There you have it. That's solving polynomial equations using synthetic and long division. All right, guys, have a great day. Hope this went well. We'll see you in the next video.